This is the third interstellar object, an object that came from outside the solar system, that was spotted by telescopes around the world. We're seeing the reflection of sunlight from a solid object, and moreover, it will get very close to Mars.
72-hour stack. In just 3 days, a string of high-energy events unfolded across sky and Earth. Two novae flared bright enough to see without a telescope. Twin magnitude 6 earthquakes struck the same region of Venezuela, and a coronal mass ejection swept along the path of the only confirmed interstellar comet now in our skies, 3I/Atlas. Scientists began calling this compressed window the 72-hour stack because so many rare events landed on top of one another. By themselves, each piece is uncommon. Together, they form a statistical outlier. On average, the world may see one naked-eye nova. In a year, sometimes none, yet two erupted within roughly 36 hours. The Venezuelan region typically experiences a magnitude 6 earthquake every 2 or 3 years. This time, 2 major quakes and a strong aftershock hit within 6 hours. Meanwhile, the Sun, near the peak of solar cycle 25, launched a CME whose modeled track intersected the projected path of 3I/ATLAS, only the third interstellar object ever confirmed. Stacking probabilities pushes the odds of such overlap below 1 in 1,000 and possibly far lower, depending on how the counts and time windows are defined. Statisticians call this Poisson clustering. Randomness can occasionally deal a hand that looks impossibly loaded. Estimates for 2 naked-eye novae inside 3 days fall under 0.002%. Back-to-back Venezuelan quakes of this size are on the order of 1 in 10,000. Add a CME arrival near an interstellar comet's corridor, and the math leaves. Even seasoned researchers reaching for the term event stack. The numbers do not prove a hidden connection, but they do justify a closer look at how tightly the timelines lock together. Minute-by-minute window. The clock starts just after midnight, Coordinated Universal Time. At 2:12 UTC on September 23rd, FAR 1935 Centauri crosses the detection threshold. Survey arrays in Chile and South Africa flag the outburst, automated alerts ripple outward, and public confirmation follows within the hour. It is still deep night locally, yet by dawn in Europe, the notice has already propagated through professional networks and amateur channels. Fast forward to 22:21 UTC on September 24th. Seismographs around the Caribbean record a sharp, shallow rupture. Magnitude 6.2 near Mene Grande, Venezuela, with an epicentral depth of about 7.8 kilometers. Local time is 6:21 p.m., early evening as residents are finishing dinner. Preliminary bulletins appear within minutes from Venezuelan seismic agencies and are mirrored by global catalogs. Less than 6 hours later, at 3:51 UTC on September 25, the ground moves again. This second main shock comes in at magnitude 6.3, slightly deeper at roughly 14 kilometers, in nearly the same zone. Within the following hour, a strong aftershock near magnitude 5.8 rattles the area. Hospitals timestamp their triage logs, while WhatsApp threads record the scramble for supplies and staffing. 14 minutes after the second earthquake, at 4:05 UTC, another astronomical alert fires. VAI 7994. Sagittari erupts into visibility, peaking near magnitude 6.2. Automated pipelines post the discovery, and multi-wavelength monitors pick up gamma-ray and hard X-ray signatures. Amateur observers trade notes with professionals as data streams settle, and calibrations are checked. Meanwhile, the Sun moves toward its own rendezvous. A CME launched the previous day sweeps through the inner solar system on September 25. Models place its interaction with the projected corridor of 3I/Atlas within an 8-hour arrival window centered on midday UTC, though the precise overlap depends on solar wind speeds and the comet's updated ephemeris. Space weather centers issue. Rolling alerts as plasma parameters update in real time. Line up those timestamps and the density becomes clear. Chilean telescopes scanning in the pre-dawn. Venezuelan hospitals improvising under power cuts after sunset. Heliophysicists refreshing solar wind plots as the CME front advances. Each marker is grounded in local reality, yet all are chained to UTC, turning the 72-hour stretch into one of the tightest multi-domain timelines in recent memory. Novae are more than sudden brightenings. They are thermonuclear runaways on white dwarfs that siphon hydrogen from a companion star. When pressure and temperature climb high enough, past about 10 million degrees, fusion ignites in a flash that ejects the star's outer shell at thousands of kilometers per second. The light can surge by factors of 100,000, and shock fronts in the expelled gas emit at optical, X-ray, and gamma-ray energies. For V1935 Centauri. Before dawn on September 23, detectors reported clear high-energy signatures as the optical peak crested, evidence of particle acceleration and shock-heated ejecta. Less than 2 days later, VI 7994 Sagittarius did the same. Multiple survey teams compared claim times, high-energy satellites verified triggers, and preprints began dissecting the shock physics. The link between the novae is not their proximity on the sky, but the violence encoded in their light curves. On the ground, the Venezuelan sequence followed well-known mechanics. A shallow 6.2 releases strain, transfers stress to adjacent segments, and a deeper 6.3 follows, with aftershocks decaying in frequency and magnitude, an Omori-type pattern. Local reports out of Mene Grande describe triage on parking lot tarps, rotating patients outdoors during aftershocks, and tracking wall cracks by flashlight. With limited operating tables and intermittent power, teams prioritized children and severe trauma, while radio stations relayed supply lists and safe routes. In a week when the universe seemed to flirt with impossibility, the crust still obeyed its own rules. Plate motions along the complex Caribbean-South American boundary continually load faults. One slip can nudge another into failure. Solar Max and Atlas. Solar Maximum is not a slogan this year. It is the daily backdrop. Sunspot counts have surged, and the 10.7-centimeter radio flux has been holding high, conditions that favor frequent gmees and a lively solar wind. Into that environment flies 3I/Atlas, an object that does not share our solar system's history. Its orbit is strongly retrograde and nearly skims the ecliptic. Its speed exceeds 60 kilometers per second, and its trajectory takes it within about 0.19 astronomical units of Mars on October 3rd. Orbiter teams on MAVEN and the ExoMars Trace Gas Orbiter have reason to watch for coma and tail responses if geometry and brightness cooperate. Community science platforms such as the AVSO, the International Comet Quarterly, and the Comet Observation Database are already posting calls for magnitude estimates, tail sketches, and time series photographs. If you record a sudden brightening, a tail kink, or a suspected disconnection event, log the time, location, and equipment, and compare notes before filing a report. Careful documentation keeps the shared dataset clean and valuable. Group sky watches benefit from a short safety briefing at dusk. Keep all optics pointed far from the sun until it is well below the horizon. Use red lights or dim screens to preserve night vision. Emphasize certified filters and responsible laser use. Excitement can tempt shortcuts, but a few simple precautions protect eyes and ensure observations that scientists can trust.